Good evening, folks. It's good to see you again. I hope I have a little bit of insights to bring to this topic today, and as with our last session, hopefully some of you were here, I brought out some of the parts of the skeletal collection of the Penn Museum that come from the MORTON collection. Today I chose a very particular subgroup. You can see that there's many fewer today. It actually is a subsection of probably about 5 or 6 dozen crania that actually came from a single burial ground in Cuba of people who were enslaved. But these people were African-born. They were not born in slavery in Cuba. And they illustrate a medical point, actually, that I'd like to make with you. But before I actually sort of launch into that part to it, for those of you who did not come last week, I thought I would give you just a tad or a bit of a background, basically, on the collection itself. So with apologies to those of you who have actually heard this before. But Samuel Morton was a Philadelphia physician and the president of the Academy of Natural Sciences here in Philadelphia. I got many excellent questions in our Q&A after my session last time, and I can now say, based on one of the questions that was asked that I had to stand down from, people had asked after his death. The collection was actually purchased by the Academy of Natural Sciences, and one of our audience members had said, how did they purchase them, from what kinds of funds? One of our very excellent students went and looked this up for me. I should have been able to have the energy to do it myself, but I didn't. And it turns out the cost of the collection when it moved from Morton's private collection to the Academy was $4,000. And they were able to acquire it from 40 donors, each of whom gave $100. So it was really a separate kind of segment from the rest of the collections at the Academy. The collection came to the Penn Museum in the 1960s. And it was at a time when the Academy basically had decided to move and look more at non-human biological specimens. So the human collection came to us, and it's been here ever since. Morton died in 1852, and his collection remains as part of our collection here. There are about 1,500 crania in total, but not all of them were collected by Morton. A portion of them were collected by his protege, a man by the name of Meigs, after his death. And I think I'd also explained last time, Morton died within 3 days of contracting an illness, so really quite suddenly, and his student took up this process. Many people ask, what do we do at the Penn Museum with the collections? How do we use them? How are they interpreted in modern scientific frameworks? All of these sorts of things. And so this is just a real basic summary of the sorts of things that we do. Each one of the specimens in our collection is researched in terms of its history. This is actually part of the next bullet point, which is collection management. That is that we make sure everything is properly identified, that it's properly stored, all of these things. Preservation goes along with that too, as you can imagine. So the collection is as it was when it came here in the 1960s, and very close to the way it was when it was actually at the Academy of Natural Sciences. We do have active research with the collection. You should know this, and we continue in this effort. And we do this by having scholars from around the world come and visit the collection. So people think, more statically, in some cases, in some senses, about collections. That's absolutely not the case. So the Morton collection has given us amazing insights, actually, into human variation. And today, with the African specimens that I'm going to show you, you'll look at a bone characteristic, which is part of anemia. We, of course, don't have the, fleshed out person and the testing facilities actually to, really come to that, nice spot where we say it's a sickle cell anemia variant that's actually affecting the crania. But we do know that these people suffered from anemia in a pretty significant way. And then, of course, the last one, and that's one of our foci here, of course, is to interpret the collection for the public. So as we move along in our time together, what's going to happen is we are going to take a Q&A after I talk a bit, and then a bit of a break, and I welcome you to come forward if you would like to look at the crania, as many people did in our last session, and I'll be down on the floor helping to assist you in every way I possibly can. All right. So the crania are stored in storage areas here in the museum. Storing 1,500 crania is actually a pretty amazing task. In order to keep them safe and balanced and not rattling or knocking into each other, they have to be precisely positioned, of course, in cabinetry to keep them in this most excellent state. Each one of them you can see is actually, each one of them is actually nicely labeled. So we have a lot of very precise information about them, not only in catalog form, but in some cases actually written on the crania themselves. So this is crania 1748. It's from Ancon, Peru. You can see the collector and the sub-collector, the person who actually was the intermediary which brought them from the collector to MORTON. We have catalogs that specifically outline the place of origin of the crania. Some of the crania we have excellent information about. Some parts of the cranial collection we don't have excellent information about. This particular part, which I brought to you today, we have excellent information on. And one of my graduate students, Emily Rentschler, about 5 years ago, wrote her dissertation on this collection and tracked back all of the archival material which is associated with them. So indeed, we are able to really nicely personalize and ground this segment of the collection. As I had talked about last time, MORTON was a fanatical person and actually accumulating what at the time, what for many people is the scientific data and measurements from the collection. We talked about the fact that MORTON, no matter how you cast him, was a racist. He probably was a polygenist. He was interested in ranking races based on skull size. He also, too, did a rankings based on the degree of projection of the face. He made comments that the, sort of more projecting the face, the more ape-like the faces actually became. So not just on the score of cranial size, but also on face size, he was, crafting essentially this hierarchy of races. We did do a significant amount on brain size in our last segment together. I'm going to carry that a bit forward this time and talk about the ways measurements are actually used today and give you the almost an identical idea, actually, and that is that all of these crania that are part of the collection coming from the 3 race groups that MORTON had so classified them into actually overlap with each other so dramatically, proving what you'd seen in the video and what Sharon was talking about. That is, there are no race characteristics actually that are biologically based in that sort of physical sense, okay, and embodied in the cranial materials themselves. One of the participants last time asked me whether or not brain size was associated with intelligence. And I had made several comments about that, and I just slipped this one slide in here to solidify this a little bit for you. There are actually some studies that have argued that brain size is associated with intelligence. As with all of these terms, they can be easy or hard actually to define. The word intelligence probably is closer to something like cultural competency. And so when they talk about it, it may be that there is some component of this which is associated with cultural competency. But I actually show the brain size, which was taken from Einstein's head and an autopsy and actually measured. So Einstein's brain weight was 1,230 grams, and you can see the average human brain size listed. So Einstein fell below that standard, and he was probably by all of our tallies a pretty smart guy. Okay. And not that we can agree on everybody and who's smart and who isn't smart, but I think that we can say, okay, Einstein is a pretty smart fellow. In terms of the crania, We do lots of different things. I'm going to focus on two things here. So I shouldn't say just cranial and skeletal materials, and I know this is kind of a busy listing of possible areas to explore. I'm going to actually just talk about paleopathology, or ancient patterns of disease. And I'm also going to talk about some of these measurement analyses which are done to derive what are called population affinities. And just so you can kind of get a feel for how people use this data today. One thing that I'm not going to talk about, or actually, but I want to point your attention to, are these things called markers of occupational stress. There's a weird looking word here, enthesiopathy. And I talk about these in terms of this particular subset of crania because what we've found actually in the crania, and you'll see it if you want to come forward and look at the crania, obviously that's an option for you to do, that a lot of these African crania lean backwards. And you might be thinking, oh, why are they seemingly a little tilted a little bit differently? Well, it is actually a marker of occupational stress. We know that these African peoples were put into this plantation setting and actually squeezed, cut, but also squeezed cane from sugar cane. Some of you might have taken chunks of sugar cane from a local supermarket, maybe to chew on them or just to get a sense of what sugar cane actually looks like. And can you imagine manually squeezing that? And of course, that takes a bunch of strong upper torso muscle effort, but those muscles actually attach onto the back of the cranium. So although the crania, are, as any human crania is, in terms of its thickness and every kind of feature associated with them, there is a buildup essentially of the places of attachment of those muscles, and the bone is very thick at the back of the skull. So we actually can probably associate that with the pattern of the ways that they were using their bodies in the past. In other words, they give us a sense of how physically challenging the lifestyle of these peoples were. And I'm often talking about not just the crania in this way, but also to the other skeletal elements which show incredible power associated with these people. So, without that kind of physical effort, much of the, the changes which occurred in the 19th century would not have happened. It was through their efforts that these great countries essentially were born, through the efforts of sugarcane production, through the efforts of planting, harvesting, spinning, weaving cotton. One time I actually did the math and found that if you actually took cotton balls, you ginned them yourself, actually pulled the 26 or so seeds out of each one of those balls, and then you made it into thread, and then you wove it into a shirt. A men's medium Hanes undershirt in labor would actually be about $250. So imagine the physicality of doing these kinds of actions. And it's easy to see that physicality in the actual skeletal collections. One of the things that I want to point your attention to is the fact that unlike most diseases, sickle cell disease actually leaves a marker or an effect on bone. As I had said, it's kind of more generalized, and I actually just stated it. We can't really tell sickle cell anemia, but we can tell anemia, because skull bones are actually, one of their processes is for the production of red blood cells. And a body which is oxygen deprived through anemia responds by the production of more red blood cells. In some cases, like this one, it doesn't matter because the delivery system is still not present, but we can see the expansion, essentially, of the spaces in bone that are responsible for red blood cell production. So this particular collection has given us or afforded us amazing insights, essentially, into the challenge of anemia in these peoples coming from these populations. And we're pretty sure, based on my student's dissertation, from a very particular place in a group of places actually in West Africa. And why am I telling you the story of sickle cell? I'm sure a lot of you know components of this, and I'll try to do my best in getting some of this information out. Sickle cell anemia is considered to be an adaptation to malaria. For those of you who are evolution people, it is through the processes of natural selection that the sickle cell gene has come to a fairly high frequency, not only in populations from Africa, but from populations in many places that are also challenged by malaria. You can see the death rate which is associated with malaria. It actually is tallied and is somewhat different each year. It's one of the leading causes of death globally. And you know, the number is really staggering of the number of individuals who actually die annually from the disease. Mosquito populations carry malaria, so of course, based on mosquito prevalence and the type of mosquitoes which are present, it waxes and wanes over the course of different years. But certainly, most places in the world that are in warmer climates, tropical and subtropical, have their dollop essentially of those mosquitoes and of malaria, including in the United States. Periodically, you'll hear about people that actually have malaria in the United States. They didn't get it from traveling. So we're not immune essentially to malaria by any means. Many organizations are there to fight malaria. I am a person who works in East Africa, and on 2 separate occasions got a variety of malaria, the one that which is called falciparum malaria, and I'm a pretty healthy adult, and I was damn sick, okay? And they estimate that in the country I was working, Kenya, the average person is a repeat person with malaria because there's only a very small amount of immune response, okay, which you can call upon on future infections with malaria. That average person probably is getting a new infusion of malaria at least 50 to 52 times in their lifetime. So we are talking really serious disease burden in some populations. The slide set goes through a lot of different components, and we'll post it up on, of course, our public classroom site. So if you would like to get the information and look at it in more detail, absolutely it's there. The disease is falling into several different types or varieties, and you can see them listed here. I've got Plasmodium falciparum, the most probably difficult version of malaria that is known in existence today. Not many drugs can actually help as a prophylactic against falciparum malaria. So even though I was compliant with drug protocols and things like this, and covered myself in DEET and covered my body, and just wound up getting that mosquito that just gave me that bite that set me into a state where I was sick for approximately 6 months. The mosquito vectors are varied, but the 2 actually that are most commonly associated with malaria are listed here. But many mosquito species can actually carry malaria. And in the US, they actually capture mosquitoes, and they, of course, find malaria within them. So it's not just something which is present in faraway places in the world. I always need to say that. There is a gene, which is the gene associated with sickle cell. That gene is an allele, basically, of a gene for a version or type of hemoglobin called hemoglobin B. In individuals who actually carry 2 versions of that gene, they have something which is called sickle cell anemia. But there is the silent part of this. Those individuals who carry 2 different alleles of that gene for beta hemoglobin, normal or regular version, usually called hemoglobin A and hemoglobin S, will actually have something which is called sickle cell trait. They're carriers of the gene. And thus, you'll hear often people talk, oh, I'm a carrier of that gene, or my mate is a carrier of that gene, and oftentimes they'll have children tested actually for the gene. The disease is devastating in terms of its effects when a person inherits both versions of the S gene, and until recently, it meant, essentially a very early death. Okay. How does this happen? And what did our ancestors have? Did our ancestors have any kind of disease state like this? The answer is absolutely not. And it has to do with, as Sharon had talked about so eloquently, it has to do with environments. In this particular case, the environment was the relationship of humans to bugs. And what had happened was there was a change that occurred because of the beginnings of agriculture in many places that were in natural forest environments. When those environments were cleared for agriculture, this changed this relationship of those environments to these mosquito populations. The mosquito populations actually rose, began transmitting malaria to these people in a very high frequency. And then we can actually mark, because there is a skeletal marker, the beginning of extreme cases, basically, of sickle cell at about 2,000 years into the past. The gene actually is said to be based on studies genetically of malaria and its sickle cell and its variants to be maybe close to 50,000 years old. So the gene is around, it's all over the place. It's in high frequency in many populations, including in Africa and the whole circum-Mediterranean world into South Asia. So it's not a variant which is very specifically localized in any realistic way. The gene actually is going to produce an anemia. There are many causes of anemia, and as I say, bone will show anemia, but it doesn't say sickle cell. I mean, it can say any kind of anemia. It can be an anemia which is nutrition-based or iron deficiency-based. So some of you, especially women, might have been diagnosed with iron deficiency anemia and been told to take in a greater amount of iron, iron supplements, iron-rich foods, these sorts of things. And basically you can offset a lot of those patterns. Changing nutrition patterns can do this in general. You can have protein deficiency anemias. In other words, it can come from a lot of causes. But in the case of the almost ubiquitous representation, essentially, in these particular crania, and given the extent of it so long that it affected bone, the thinking is that it probably is a sickle cell version of anemia rather than a nutrition-based one. There are many sort of technical kind of components of this, and one of the things, of course, that happens and why it's named the way it's named is because red blood cells actually alter in shape when they dump their oxygen to peripheral tissues, and when they alter in shape, they form a sickle shape. And mechanically, often, these sickle cells block capillaries, and that, of course, makes many of the tissues that those capillaries supply with oxygen deprived. So a person who has sickle cell actually is in incredible pain and also is going to witness a great deal of organ damage. Okay? And well recognized, okay, basically the cause mechanically and genetically of this particular disease. So of course you can see the shape differences. You can see a stamp which was actually produced in the United States talking about or making the public aware of the sickle cell gene. And then of course we can even see the details of the arterial and capillary action that delivers those normal red blood cells and sickle red blood cells to all of the really cells and tissues in the body. The way it looks on bone is this. So I challenge you, and I'll stand by the tables and I'll show you these areas on bone that are perforated and these patterns which are associated with anemia. So you can see this pitting and pockmark kind of action in the eye orbits. In bone, it's called cribororbitalia, and it's one of the indicators of anemia. And then, if I have time, actually, I don't know, I have 1 minute. I don't know that I can manage. I wanted to actually do 2 other things we can do with the collection. Kate's going to throw me off the stage. And if I can't do it today, I'll happily do it in our next sessions together. That the crania from the MORTON material has been used in a number of different studies, and the identity of, they call it ancestry, but oftentimes in this context it actually can mean race. They take copious numbers of measurements on the crania. They do all sorts of comparisons, and they have, basically in the end shown that there's a huge amount of variation essentially in the crania of the peoples from all over the globe, including these African crania. And we actually can't, by sets of even very broad measurements, distinguish between different groups of ethnic origin or ancestry origin. The one slide that I want to show here actually has to do with the recognition on the crania of males and females, and this is actually work that we did here, and we were able to show basically the differences in the crania between males and females. So you can see the places that we go from red to orange, males are larger than females. And one of the ways that males and females in the crania actually distinguish from each other is through asymmetries, actually. Male crania have a greater asymmetry than do female crania. And so, of course, we were testing, does it appear when they're young? Does it only happen in older individuals? Is this associated with muscle action? So we actually did our own sort of sex determination on the crania, but others have done this thing with looking at population affinities of the crania. I talk about it because it's so interesting forensically also. And I want to go through these way, way too quickly, talk about, basically the problems in doing any of these kinds of analyses. We actually took crania that didn't derive from the populations that were used to create these mathematical ways of discriminating between the populations. We have a large collection from the Middle East, and all our Middle Easterners came out as Chinese men. And I'm not really too sure why, actually, and I've looked at them many times. We had 10 people measure them. I thought I was, just crazy in my own measurements, but not the case. The measurements that are taken by physical anthropologists are, huge. I mean, there are hundreds of measurements which are taken. And I'm just giving you a small sense of some of the points and some of the measurements which are done. And then listing of the problems, especially with things like mixed ancestry. And this is the representation of those hundreds of measurements drawn in two-dimensional space to show you the amazing overlap between human populations. So you see all of these circles actually represent the range of variation of one grouping of skeletons. And in this case, I'm pointing actually at black males. You can see black females, white males, and you can see that there's really no way to discriminate these. So indeed, it is the case that there is no biological basis to race. Anyway, I thought I would take a couple questions, and then we can do our break and actually have a little bit of a show, essentially, of the crania as I just talked about them. And then a break again, a real break, and then come back and meet with our panelists. Okay? I'd love a question. Come on up to the mic.
So it seems like in the study you just described, first of all, thank you very much. This is fascinating. I'm just curious, what was some of the early research that disproved phrenology? Because it seems like what you've got is a modern continuation of that research, which is disproving crania-based ethnic determination.
Yes. I mean, it's interesting that you put those things together. Phrenology literally was the feeling, not so much of the measurement of point to point, but actually the measurement of bumps in particular places. And the field that did the most sort of solid damage to that work in phrenology was in the beginnings, really, of psychology. So, it came from somewhat of a different direction. The people who do these measurements are not looking just at these shape-deformed areas, that just sort of appear kind of randomly on the cranium, but we're actually doing a certain group of over those bump detail kinds of measurements to get a sense of overall shape of the crania versus just the eruptions essentially in different places associated with personality characteristics. I have a big bump in a place, and we have phrenologic skulls in the collection, and my big bump on my head means that I'm very circumspect. And we know that's not true, actually. I also try to feel in the upper part of my eye for my asocial bump, and that I absolutely have. No other questions? Oh, I'm so sad. Please go ahead on up to the mic. Yeah.
Thank you very much.
Thank you.
I have a question. As you were concluding, you used the term mixed background, I think you said.
Mixed ancestry, yeah.
Yeah, so it's not unusual in black families, what we call black people. When a child is born, sometimes the child is very fair.
Mm-hmm.
And then, according to people who know, typically the older women in the family, they'll say, it's okay, the kid will get darker. But so when you say mixed ancestry, do you mean what we typically call biracial, or the fact that you've made the statement there's no biological basis for race? In my view, we're all of mixed ancestry.
We are
So I'm trying to
absolutely,
understand that.
yes, we are absolutely all of mixed ancestry. And while Sharon was talking, my colleague behind me, Carolyn Rouse, who you'll hear on the panel, actually whispered in my ear and she said, we're all African, and then a bunch of other little things that happen or pop up here or there, okay? So what they usually mean biracial or multiracial, if they're gonna use the word race. So it is indeed the case that there's no pure race, basically, in humans, that we have not only the recent history of, peoples mixing with each other, but it's through millions of years of our ancestry. So to parse people into these little pockets or groups is so fallacious that anybody who deals with these kinds of studies, as well as many other individuals, really has to sit that categorization aside. Just let it go, basically. And some people will argue, this particulars of ancestry. So, who is, what is the lineage of your whole family? And they'll take that as a way of understanding their identity, okay, in terms of population, versus doing any of these, broad, sweeping kinds of ways of talking about race.
Gotcha.
Yeah. Thank you.